Next, let us discuss the elements that are used in the circuit analysis. The first of them is the resistance. Now, what is resistance? Basically, resistance is an inherent property of a conductor by which it opposes the flow of current. Remember, it opposes the current. Now, it is analogous to inertia in your mechanical domain. What is inertia? It is the inherent property of a body by which it opposes the change in the state of motion. Like if there is a heavy element, if you try to move it, you will have to apply more force because there is more opposition. Similarly, in a circuit, if a resistance is high, we have to apply more voltage to circulate the same amount of current. It is analogous to your mechanical system in heavy element. More force is required for same amount of displacement. Similarly, an electrical element higher resistance implies more voltage is required to circulate same amount of current. That is, it opposes the flow of current. It is the inherent property of any conductor or any electrical element. Now usually we model the resistance as a linear relationship between voltage and current. That is, if you draw a VI curve, the slope is modeled as a resistance. And as I told you, you will consider it as a time invariant, that is Vt is equals to It into R. The resistance is not considered as a function of time. Now if you take a Laplace transform on both the sides, it becomes Vs is equals to Is into R. That is, the ratio of Laplace transform is equals to R. Usually the ratio of Laplace transform is known as a transfer function. So the transfer function of a resistance is equal to the value of the resistance, that is R. Here I am assuming the input is the voltage and output is the current. Okay. Now in terms of sinusoidal excitation, we will study later on that we will model the voltage and current as a phasor. There also V is equals to IR. Due to the resistance, voltage and currents are in the same phase. Because it is a constant factor. Resistance is a constant factor. It is not providing any phase shift. Now what is the power of a resistor? Power is the rate of work done. Okay, dW by dt. That is dW by dq. If you apply chain rule, dq by dt. Now dW by dq is a potential and dq by dt is a current. So the electrical power is equals to voltage into current. In our case, voltage into current will come out to be I square into R, or we can say V square by R. I am replacing V is equals to IR, it becomes I square R. In place of V, I am putting V is equals to IR. What about the energy? To determine the energy, actually power is the time rate change of energy. Power is actually dW by dt. So what is the work done or the energy stored? That is, it becomes work done is equals to integral P into dt. That is, if you put the value of P, it becomes I square R into dt. Usually what we do is, if you want to calculate average power, how to calculate average power of any quantity? Average power is equals to 1 by T integral I square R into dt. Here R is the constant, you can take it outside. It becomes 1 by T into integral I square dt. Okay. Now we can write further it as a I RMS square into R. It is the expression of I RMS square. Okay. So I have replaced it by I RMS square. So whenever we have a time varying current, that is current is following the function of a time. Let us say current is equals to sin t. So it is a function of time. Then you have to use the RMS value of the current to determine the average power loss in the resistor. Okay. And you can also write this expression as a V RMS square by R. Now basically what does the resistor do in terms of power? Usually the working of resistance is to convert electrical energy into heat energy. So do not think that the resistance dissipates the power. It is not like this. Resistance converts electrical energy into heat energy. It is not necessarily dissipating the power. Why? Because what happens, suppose we are using a heater. Then there is a resistive element which will heat up the surrounding. That energy is actually being utilized by us. It is not being wasted. So resistance does not necessarily waste the power. If it is a part of a load, it is actually consuming power and giving us out the heat energy. But if it is a parasitic resistance, that is, it is not a part of load or it is undesired, then actually it is wasting the power. Like suppose I am transmitting the power from source to load by means of transmission line. The resistance of transmission line will cause the power loss from the supply to load. That resistance is undesirable. But if I had the load and you have connected a heater, that resistance is designed because it is giving you the heat energy which you can utilize in order to even cook food. That is a basic principle of your induction cooker. It utilizes the electrical energy and converts it into the heat energy in order for you to cook food. How is that energy wasted? That is actually being utilized. Okay?